So now, here we have the 555 timer in astable mode. Astable means there's no stable state for the output. As you can see there, it keeps flashing red LED, blue LED. Red LED is when the output is high, blue LED is when the output is low. We'll look at that right now. So when the output's high, it's connected to the positive supply as good as it can. You actually lose a fair amount of voltage, and just from the transistors inside. Something to keep in mind for this particular component. I'm using the NE555. Micro A555 should be the same. If you got some different version of 555, it may have different output properties. Be aware of that. So in any case, high output, red LED lights up. I got a 220 ohm resistor, as I said before, and if you see doing something kind of weird, if I bump the power supply, it can affect the output too. But in any case, we have the red LED. They are not as bright as blue LEDs, and we got lower voltage going across it, therefore lower value resistor to help get it about as bright as the blue LEDs. Get somewhat close. We could go even lower in resistance if we want. Now, when output is low, it's connected to ground. Usually connects to ground pretty good, these integrated circuits. And so we got blue LED, 1000 ohm resistor, so more than 4 times the resistance than the red LED. So we have the reset pin. Also, that's to the positive supply right there. We don't want to reset this circuit right here. If we give it a low voltage, if I put that jumper to the negative supply instead, it's just going to keep the output low at all times. So we put it to the positive supply so that it doesn't do anything. Reset puts the output low, and it keeps it there as long as it's being reset. Now, we come to the timing part of the circuit, and we'll zoom in because pretty much I got everything on the right side of the board right there, and the timing part of the circuit's on the left hand side of the schematic, so they line up pretty nicely for looking at things in detail. I'll move this capacitor so you can see the connections a little bit better right there. So, well, the output is high. Pin 7 is not doing anything, and these are connected. I know a lot of people like dots. I'm using the system where if there's nothing, if the lines are touching, that means they're connected. If they weren't connected, there'd be a jump one way or the other. So get used to both systems. Now we have the capacitor charging. While it's charging, the output's high. Pin 7 is not connected to anything. Pin 2 and pin 6 just look at voltages at all times. While it's charging, so it's going through a 10K resistor, the diode, and into the capacitor right there, till it gets to 2/3 of the supply voltage. So the value of the capacitor or resistor up there and the capacitor are what determines how long it takes for it to charge. The two values. If you go higher on one or both of them, it's going to take longer. If you go shorter in value of one or both of them, it's going to go quicker. So gets to 2/3 supply voltage, and then pin 7 connects to ground to discharge the capacitor, and the output also goes low. So when pin 3 is connected to ground, low output, pin 7 is also connected to ground. One thing to be aware of to help simplify how this works. Now, pin 7 is connected to ground. Any current getting through that 10K resistor just goes right to ground. So you can't go extremely low in resistance for this resistor right there. You want to make sure you limit current for when it's connected directly to ground. But we have the capacitor. It can't discharge through the diode. That's why we use that diode to let it charge through one resistor. And then it can't go back that way. So it will discharge through that 10K resistor. So it's charging through a 10K resistor and discharging through a 10K resistor. And the diode, being part of the charge circuit doesn't really affect the timing very much. It equals out, pretty well. Not perfectly, but pretty well. And discharges to ground right there while the output is low, same time, until pin 2 sees 1/3 or less of the supply voltage. So they're both looking at different voltage ranges right there. And you could even use some 555 timer. I mean, you can use this one, but remember, it falls short of the positive supply right there. To charge, you could have resistance that charges and discharges the capacitor via the output. You'll see that sometimes. But usually this is more common of a system. But just be aware that the capacitor is working in the same direction as the output. It helps simplify what the component's doing if you're always aware of that. So yeah, it discharges to 1/3 and then stops discharging until it charges up to 2/3 and so on. Keeps bouncing back and forth. Right there, that's how it works. So that's how the 555 was made, but there's all kinds of modifications you can make. So recent videos we looked at the bistable, where instead of a capacitor charging, we just had a couple switches where you either gave a low enough voltage to pin 2 or a high enough voltage to pin 6 to change the output. And then a monostable mode, all the capacitor did when it came to timing was charge, and then as soon as it charged to 2/3 supply voltage, it instantly discharged. You know, there was no resistance to discharge it. So there's tons of ways to modify these circuits. Pin 5, you'll often see a little capacitor, and going to ground just to help to stabilize that 2/3 and 1/3 supply voltage. It connects directly to the 2/3 supply voltage. And so you can actually change where the 2/3 supply voltage is, and then the 1/3 supply voltage will also change. It'll be half of whatever you set that 2/3 to. So just be aware of that. All kinds of ways to modify it. And you can see we got the resistor there going to the discharge pin, pin 7, and so it's kind of crowded there. I'll take a closer look there. There's our diode. There's a gray band right there. I can see it in person really easy. This one doesn't stand out very much, even in person. And the camera makes it a little harder to see it. But there is the gray band on the side that connects the pin, that wire connects to the capacitor there, and the resistor. We got that little gap there. And for connecting pin 6 and pin 2 together, I don't know how they would do that, like on a circuit board or something. Probably have a trace that runs like around or something. But in any case, this is just what I do for the breadboard right there. It seems to work out pretty well. Of course, you wouldn't be able to replace this component, so I'd probably just make a longer jumper that wraps around if I had it like on a permanent board or something, where I might have to replace the component. But this is just for demonstration circuits purposes. And of course, you always have to power it. Positive supply to pin 8 and negative supply to pin number 1 right there. As always, this is a dual inline package. There's longer integrated circuits that come in the dual inline package, but the numbering system works top left, and there's usually either a divot at the top. We just have the one on here. I have other 555s where there's also a little indent to the left right there. So there could be one or the other or both. And you start top left, 1, 2, 3, 4, and if it's longer, you keep going down, and then you jump across. In this case, 5, 6, 7, 8, right there. So pretty straightforward. And yeah, I think I pretty much covered everything. Of course, if you're new to using LEDs and diodes in general, the band is where the cathode is. And with LEDs, they're diodes that emit light, so there's arrows coming out to indicate they emit light. Other things have arrows or something coming in to indicate it's responding to something coming in. And sometimes the bar is changed. Usually there's like some extra lines going in different directions and stuff to indicate it's a different type of diode. This is just a regular rectifier diode. You can use any rectifier diode you want, and they drop about 0.7 volts right there. So they don't all look like this, and I bumped something, so kind of lost their connection. So yeah, just be aware of that. This is also a polarized capacitor. So it's another thing. If you're completely new to electronics, which a lot of my viewers are, you got to put this in the right way. So that side needs to be more negatively charged than that side at all times right there. I mean, you can completely discharge it, but when you do charge it, this side needs to be more negative, that side needs to be more positive. And these larger ones are really easy to read their value there, 100 microfarad. And you can work with up to 50 volts, but you can go any amount lower than that too. That's perfectly fine right there. So yeah, make sure you put that in the right way, because mostly at higher voltages, if you just briefly charge it the wrong direction at a low voltage, probably nothing will happen. But if you just charge it the wrong way at a high voltage, there's a good chance that it could explode, and to prevent explosions, that's why they have that little indent in the top there. Hopefully it'll just vent gas, but you never know for sure. So in any case, yeah, that's about it. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.